Thursday and Friday of last week, we got introduced to trig equations. Thursday, it was just linear equations. We solved for the trig expression. We thought about what quadrants it was defined in, or what quadrants it was positive or negative. Got our answers, typically about 2 answers on Thursday. Then we got to Friday and we started looking at the quadratic version, which is what we have in our warm-up. We found different ways of factoring or square rooting depending on the format of the equation, or we looked at GCFs was another thing that we saw on Friday with our different types of equations that we saw. And we ended up getting a lot more answers to a lot of those questions. This was one of those. Again, if you're having a hard time seeing it, try taking out the distraction of trig and thinking of the equation 2a squared equals 4a plus 6. And I see that I got an a squared and a and a plain number. Tells me that we would have to factor. And if you need to factor with it being an a, don't forget to put the sign of x back in before you finish the problem. In this one, I would have moved everything to the left-hand side because that's what would have made my quadratic positive. I don't have a GCF because the 6 does not have a sign. So GCF is not the route. This is going to have to be factored. I guess it does have a GCF of 2. I could factor a 2 out front. That does not have a sign x, but it might help me factor this easier. I'm looking for factors of 3 that add up to, that I made that a positive 6. Let's try this again. Solve my equation correctly. Factors of -3 that add up to -2. Factoring with a sign, so sign and sign, which we have a -3 and a positive 1. Setting everything equal to 0, not needing to set the 2 equal to 0 because it doesn't have a sign of x or an x or anything. So it's not going to impact our answer, just like normal factoring, right? It doesn't have a variable. It doesn't change my list of answers. Set anything that does have a variable equal to 0. If you did not factor out the 2, guys, you will get the same answers at the end through the solving process because you'll eventually divide by that, and that's fine, okay? This first one is a reminder that sign has a range of -1 to 1. 3 is outside of that range. So there is no number that I can plug into the sign of x such that I get an answer of 3. The biggest answer I can get is 1, okay? What that means is we don't get any answers from this part of the equation. If that happens to the other side as well, then I would say no solution. But let's see if on the other equation we get a solution. And we get sign of x equals -1. That falls on my axis. That is down here at 3 pi over 2. So we get an answer, and it is 3 pi over 2. Questions? As we are building our way through this section, we have gotten to the most complex part of it. They will look today probably like the equations from Friday, but not worked out nicely for us, okay? And that will be your indication that we have to go to our option that we are about to talk about today. So the first part is still in the non-calculator area. And as you first look at this problem, I would say that it looks just like Friday's did, right? We've got a 2 cosine squared x plus 3 sine x equals 0. And it looks to me like a quadratic equation. But upon further inspection, what do you see that's kind of weird about this one that just doesn't quite mesh with what we did Friday? We can't really simplify this, can we? We've got mixed trig functions up there. We saw mixed trig functions on Friday, didn't we? But we were able to factor out a GCF. Can you factor out a GCF to get like my trig function separated in this? No. The first function has cosine squared. The second term just has a sine, no GCF. They don't have anything in common, okay? Obviously, I would start there. If I had a GCF and I can factor it out, that's going to be the easier route, but we don't have that option. And so then what we have to go to today is looking at, okay, we actually have options of ways that I could replace something like a cosine squared with an identity. And so today we're going to look at altering the equations by replacing things with an identity. So now what I want you to do is go to your identity sheet. Why did I pick cosine squared? Well, I picked the cosine squared up here as what I want to replace because it has an easy identity. Typically, you will pick the squared term, or as we see on the next example, the double angle formula. Because it has something that I can replace it with. Now, looking at my options, there are not a lot of options to replace cosine squared with. 1 over secant squared would be an option, but that does not seem to be helpful. The Pythagorean identity is actually where we're going to be looking for today. Your Pythagorean identities give us an option. And what happens is if I replace this part of it with its Pythagorean identity, which is 1 minus sine squared, finding that Pythagorean identity on your sheet, fill that in. And what we see now is an equation that only has signs throughout, sine squared, sine, plain number, okay? And that leads us now to something we can work with. So as I now use my algebra to simplify this, I would have 2 minus 2 sine squared x plus 3 sine x, and this is a problem that we can now work with better. Now, with my quadratic term, I'm going to rearrange all of this because my quadratic term right now is negative. It's really challenging to factor with your quadratic term negative. So what I would do on this is either factor out a negative or essentially add everything over to the right-hand side so that we are dealing with a positive quadratic term. So I'm going to add this negative 2 sine of x. I'm going to add 2 sine squared x to the other side. Subtract 3 sine of x. Subtract 2. Yes. What did I? Why did I do that? Because right now, if I were to reorder this, I would have a negative 2 sine squared. And it's really tough to factor if you have like a negative 2x squared plus 3x plus 2. It's really tricky to correctly factor if your quadratic term is negative. So I always do something to make my quadratic term, whether that be factor out a negative or add it to the other side or whatever. We are way more successful if we make that quadratic term positive. And so that's what I did. Now I use my method for factoring, whether that is slide and divide or split the middle or guess and check, whatever your method is, because I have a leading coefficient of other than 1. It's a 2. So I'm going to have to think through how this would factor. I'm a guess and checker. Factors of 2 are 2 and 1. So I know I have a 2 sine of x and a 1 sine of x. And then I have to strategically fill in my factors of negative 2 so that when I multiply my outsides and insides and add those, I get negative 3. And I think that's going to end up being negative 2 times negative 2 would be negative 4. And then 1 times 1 would be 1. Well, negative 4 plus 1 is negative 3. Use your method. Order does not matter as long as one of your parentheses has 2 sine of x plus 1 and one of your parentheses has 1 sine of x minus 2. You are correct. Then we just can finish out this. Once we get to this point, guys, we're back to Friday. We set each part equal to 0. And solve this one should start kind of standing out to us as I solve that. Sine of x, can sine of x ever equal 2? No. So we don't get any additional answers from that side. I'm going to go back over to the other side, subtract 1 and divide by 2, and I get sine of x equals negative 1/2. Did I do that too quickly? You all okay with that? Then I have to force myself to think through. All students take calc. Let's get this process back in our brains, right? Sine is negative in quadrants 3 and 4. So as I go to list my answers, I should have an answer from quadrant 3 and I should have an answer from quadrant 4. And we're only doing from 0 to 2 pi, so I don't have to do that plus 2 and pi thing. My reference angle that gives me a sine value of 1/2, now we go to our method, should be a pi over 6. Are we all agreeing with that? And the pi over 6 that puts me into quadrant 3 would be 7 pi over 6. And the pi over 6 that puts me into quadrant 4 would be 11 pi over 6. And so I get two answers for this problem, 7 pi over 6 and 11 pi over 6. So the new part today, when I went to start the problem, I didn't have options to factor, no GCF. They weren't the same trig function. And so when we kind of run through those options and I can't proceed, then our next step is to think, can I replace something with a trig, with a identity? Okay, so if it is a squared term that I'm trying to replace, you're going to use your trig identities. So typically we will be going to a sine or a cosine. So replacing a cosine squared with 1 minus sine squared, or the other way around, replacing a sine squared with a 1 minus cosine squared. The other format that we will see this in is a double angle replacement. When you see a double angle, remember that cosine of 2x is not the same thing as either cosine squared or 2 times cosine of x, right? So this one does take a little bit of discussion because there are options. We're going to pick the option that is the best for us. So will you please look down at your cheat sheet on your double angle formulas? You should have 3 options listed for cosine of 2x or cosine of 2 theta. Okay, you guys all finding that? We've got our cosine squared minus sine squared. We've got our 2 cosine squared minus 1. And then we've got the last one, 1 minus 2 sine squared. So the question always is, well, which one am I supposed to use? There is not a set answer to this. What I will tell you is if it is a cosine of 2 theta that you are replacing, let the rest of the equation decide for you. What I want to do, you have to replace a double angle. You have no option. You cannot do anything with this. You must replace a double angle. Always. It doesn't matter. There is no option to proceed forward. Even if the other term in there said cosine, you cannot proceed forward with a double angle. So we replace it. Well, let the other part of the equation guide you when it is a cosine of 2x. Pick the one that matches the other trig function that is there. Because the other trig function that is there is a sine of x, I'm going to pick the one that matches this. Okay, because the other trig function that is in my equation is a sine of x, as I scan through my options, I'm going to pick the one that uses sine of x. So I'm going to replace my cosine of 2x with 1 minus 2 sine squared x. Why did I pick that one again? Because it has a sine and the other function in my equation was already a sine. So there is not one particular one. Now, what if I picked the wrong one? It just means you would have more work to do because then you would have to do another replacement using a Pythagorean identity, and we might as well save ourselves some work and just strategically pick the one that matches the other function in there. If my other function had been cosine, I would have picked the one that had a cosine in it. Questions? Okay. Continuing on from here, we clean it up. Again, my quadratic term is negative, just like we saw on the last page. And so I would strategically clean this one up so that my trig function is going to be positive. If I combine my like terms here, one of your options would be to add everything to the other side. The other option would just be to factor out a -1. So that you have seen both options, here you go. Questions? So like I said, on the last page, I just added everything over to the other side to take care of the fact that that quadratic term was negative, and then it became positive when I moved it to the other side, or you could just factor out a negative and making sure, again, to change the signs on everything. Continue factoring here. So factors of 2 would be 2 and 1. Let's see, I need factors of 3 so that we, oh, I can't add, can I? Nobody was going to stop me? It's not 3. -2 plus 1 is -1. You guys, why was nobody going to stop me? -2 plus 1 is -1, not -3. Now we can factor. It is a 1 and a 1, but we have to figure out where to put the negative. Again, use your method, whatever your method is. I need a -3 here, so let's see. Oh, it's just negative and negative. Again, via your method, order does not matter as long as you have those 2 parentheses in there. You should be good. Set each of those equal to 0 to solve. Add 1, divide by 2. Sign is positive in quadrants 1 and 2. Same reference angle, but different quadrants this time, right? Logan. Nothing. It doesn't have a variable, so it won't impact our answer. Where were we at? Okay, reference angle to give me a sine value of 1/2 would be pi over 6, and the pi over 6 in quadrant 1 is pi over 6, and the pi over 6 that is in quadrant 2 would be 5 pi over 6. And again, no plus 2n pi because it just said from 0 to 2 pi. And then sine of x equaling 1 is going to be on an axis. So I go through my axis. Remember, we're considering the second number in each of our ordered pairs for the sine value. So like on this first angle of 0, sine is 0. And we go through those 4 and see where sine, the second number, is 1. And that happens up here, 0, 1. Your sine value is 1, and that is an angle pi over 2. So our answer would be pi over 2. So we get 3 answers: pi over 6, 5 pi over 6, and pi over 2. Okay, those are the only examples I have for you today as far as trig identities that you have to replace it with. So let's just recap those real quick. Anytime it is a double angle, you have to replace it with a double angle formula. If it had said sine of 2x, you don't have a choice. You use the one and only option. But if it says cosine of 2x, slow down and pick strategically. Pick to match the other function that's in the equation, if there is another function in the equation. If not, pick whichever one you want. Okay. If, like the first one, it looks like a problem from Friday and it's just like a sine squared or a cosine squared, but it does not match the other trig function in there, you can't move forward. Replace it with its Pythagorean identity. Okay. So again, like I said, those are my only 2 examples for you today of where we will replace with trig identities to help us solving our equations. The last thing we are going to look at today, so skip your next couple examples. The last thing we're going to look at today is how to do this on a calculator. Okay. So using a calculator to solve a trig equation, your directions do say to solve to 4 decimal places. So we will write out 4 decimal places as we write out our answers on our calculators. One of the things that you will need to do is have your trig equation solved for. So make sure that you are solved for your trig equation or trig expression. So had I had like a +3 or a ×2 in front of it, I would get it by itself first. And then what we're going to do is we're going to go type these into y1 and y2. So one side of your equation and then the other side of your equation. And I will show you on my calculator here. Let's see if I can pull this off to the side. Maybe. There we go. Okay. First of all, hit your mode button. Most of the time this year we've been in degrees, but as we are solving these, we need to be in radians. So will you please hit your mode button? Look down on your calculator. Mine is currently in degree mode. I want to arrow down so where my cursor is highlighting radian and hit enter so that if I move off that line, radian is now the one that is highlighted. Go to my y equals. Make sure nothing is highlighted at the top. Make sure you don't have a plot 1 or plot 2 highlighted. That will get in the way of graphing this, okay? One of those lines will be one side of the equation, your trig expression, whatever it is, tangent x. The other one will be the other side of the equation, whatever number it equals. This number right here, make a note for yourself, will help us with our window. Because what your graph will do when it graphs 12.8044 is a straight line up at 12.8044. So I'm going to need to be able to see that high on my graph. So as we go set our window, a couple notes. This will be how we set our X values for our window. This will guide the Y values for the window. Okay, so let me show you how I use those. 0 to 2 pi is exactly how, so hit your window button. I'm going to go on my X minimum 0 and my X maximum will be 2 pi. When you type in pi, it'll start looking like pi, but when you move off that line, it'll put the decimal equivalent and that is just fine. It'll be 6 point something, okay? You don't need to change your scale. And then my Y value, I need to be able to see past 12. Give yourself a little bit of breathing room in there. So maybe I'll go from like 0 to 15 or 13 or so. It's got to be something higher than 12.8. And like I said, I would give myself a little bit of breathing room as I do that. And then I'm going to graph. And it should graph 2 lines, one horizontal line and one with the tangent line. The blue is my tangent. The red is my 12.8044. Let's pause there. That is not our answer. It is, but we need to get to this point. Anyone having trouble getting their picture to look like that? Radian mode, Y1 and Y2. Set your window. Okay, your notes-taking purposes on this are writing down what buttons we push or reminders or how we set our window, things like that, because there's really no other notes to take for this. But here's how I find my answers. If you look at this picture, our graph intersects twice. There is an answer right here where they intersect, and there's an answer right here where they intersect, and my calculator is going to tell me what those are. So here are the buttons you push. Second, trace or calc, whichever way you want to write that for yourself. Second, calc. And we're going to find our intersection. So it's option 5 where it says intersect. And what's going to happen is your calculator will put a little bug out there. Now, sometimes that bug's hard to see. My bug is hard to see right now. It is a little blinky bug right here. You can move your bug by moving right or left. If you can't see it, you can. This tells you where your bug is. Remember this e to the -10, that's like 0, right? Anytime it's e negative number, it's 0. My bug is down here right now at 3.14. It's down at pi and 0, okay? I can either move it right or left by using my right or left, and it's going to move along my blue graph. It's going to move along whatever is in Y1. Here's a secret. It is faster to move along your horizontal line than your curvy line. And if I hit up or down, it will move to the other equation. So I just jumped my bug to my horizontal line and it's faster to move along that guy. Okay. So what I want to do is I want to move my bug close to one of those points of intersection. It doesn't have to be right on top of it. It just has to be close. And what your calculator is doing right now is asking you first curve, which doesn't matter which one is first or second. But you just need to put your bug close to the intersection and hit enter. And it's going to jump to your other equation, which is fine. At this point, once you are close to that point of intersection, you're just going to hit enter 3 times. So I hit enter once. I hit enter again. And it's going to ask me guess. We don't need to do that. Hit enter again. And it's going to tell me where they intersect. And now your bug should be blinking over one of those points of intersection. Sarah. I will. Write down that point here. For your point of intersection, guys, the second number should be 12.8044. You don't need that. You need x equals. x equals 4 point, and they told us specifically 4 decimal places. 6, 3, 4, 4, comma. Okay, try it again. Go to that other intersection while I'm helping Sarah here. Okay, you can't have a plot highlighted, so we're going to arrow up there.
Oh, that's probably why. Okay. Thank you.
Yep. You just need to keep hitting enter. 3 times you have to hit enter to get to that. Yep. Okay. If you were not able to do this on your own, I'm going to walk through it again, button by button. Again, maybe you consider writing down what buttons you push. Here we go. I'm going to find this one right here. So I will go to second, calc, intersect. I like to move along the horizontal line. So to get to the horizontal line, I will jump my bug up there by hitting up because it's faster and I don't lose my bug. So I'm going to arrow over here to the left until I am closer to that point of intersection than I was to the other point of intersection. And actually, I'm going to move past it here. Whoa, whoa, okay. Once I am close to the point of intersection that I'm trying to find, and I have started that intersect thing, I hit enter 3 times, because right now it's asking me first curve. Great. Second curve. Great. Yes. Nope. Intersection 1.492. Round correctly. 9. How are we doing? There's a lot of little nuances on our calculator to figure out how to set our window, how to find our intersections. Logan. Oh, I was just talking, that's your 2 parts of the equation. So left side of the equation, right side of the equation. That was just me talking through what we were going to do on our calculator. Other questions? Let's try one more. Actually, we're going to try 2 more because the last one has a double angle in it. That's fine. Okay, so I'm going to walk through this one again. I know that's kind of small up there. It says cosine of x equals negative 0.4317. Negative 0.4317. Already solved for. So I'm going to go to my y equals, put in cosine of x, put in one side of the equation, put in the other side of the equation, negative 0.4317. And remember how we set our window. 0 to 2 pi is your x's, and then let that number on the other side that we are going to have our horizontal line at guide our selection for this. So as I set my window, this would not be a good window because I actually wouldn't even see that number right now, would I? Okay, that is a very small number. That's like negative 0.5. I don't want to see much more than that because it's just a lot to move around. So maybe I go to like -1 or -2 and up to like 0. I don't need to see positive numbers, do I? Oh, that's the wrong line. Sorry. I should not have changed that. 2 pi. My y values. Let's try that again. Y minimum, I need to go down to -2. Y max, maybe up to 0. If you get those in the flipped order, let me show you. Let me flip those. If I accidentally flip these, this is what my calculator is going to error message me. Window range means you got something wrong with like your x mins, x maxes. Maybe they're the same, whatever. If you ever need to reset that, just reset your calculator. Go fix that. Zero to 2 pi, and then again, I just picked numbers low enough and high enough that I see this on my y range. -2 to 0 would sandwich that -0.5-ish number. And then I go find that by using my intersect. So second, calc, intersect. Again, your bug will probably jump to your trig function, but it's easier for me to move along my horizontal line. So I first things first, just jump up to the horizontal line, and then I arrow closer to one intersection than the other. Enter, enter, enter. And it tells me our first intersection is 2.0172. Okay, if you need to watch me hit those buttons again, I'm about to do it again. To find my other point of intersection, second calc, intersect. Again, if I move along this line right here, I'm moving along, and I can, that is fine, it just usually takes longer. So I could arrow up to the other one and move along my horizontal line. Up and down moves you between the two equations. Right and left moves you right and left. Okay, enter, enter, enter once I get close to that point of intersection that I'm trying to find. So enter, enter, enter. And it tells me that it is at 4.2660, which you don't have to write the 0. Questions? Okay, last one, and this is going to be kind of our check for understanding here. Different than what is on your page, so make sure that you write that down on your page. You do not have the double angle in there. Please put that in there. There is nothing to solve. That is exactly what you go type into your y1 and y2. So I'm going to go to my y1 and type in tangent of 2x, and then y2 is 3.1044. I'm going to let you work ahead of me on this one, and I'm going to just circulate to help if we were having troubles getting this started on our calculator. It's purely based off of this number. So my number right now that I have in my y2 is 3. So like I would go like 0 to 5. Yep. Some that's going to sandwich that number. Yeah.
And you never change those?
Nope. That will always be this, whatever this is, which is always going to be. Yes. Only change y min and y max. Yes. I got a lot of questions here. You would do all 4. Yep. That was your question too? Did I see a question over here?
I was just asking.
Same. Guys, we have more intersections on this one. You should have now as many as you see in your picture because we set our window to the range they asked us for from 0 to 2 pi. So every point that you see in that window should be part of your answer. Again, I would strongly suggest moving your bug to the horizontal line. It is a lot easier and faster, and you won't lose it. You can move along your tangent, but it's going to move off the screen, and then that gets confusing. All right, I am going to do this one on my calculator now. So if you're having trouble, when it is a double angle, there's nothing to solve. You just type in exactly what's there. Tangent of 2x is what I would put in that y1. y2, they say, is 3.1044. My window, the x min and max will never change, 0 to 2 pi. The y min and max, I need to just pick to appropriately show the horizontal line of 3-ish, which would maybe like go from 0 to 5. Okay, something that 3 is going to be in the range of. Again, I want to show you guys, if I don't switch to my horizontal line, you can still move your bug around, but it may go off the screen. My bug is currently here. If I move to the left, my bug is no longer visible, but I can follow it here. And it's tricky to jump from line to line. So I would hit the up or down arrow to move my bug to that horizontal line. I would move closer to one of the points of intersection. Once I get there, I just hit enter, 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 and get my answers. One of them 0.6296. Jump up to that horizontal line, move closer to your next point of intersection. Enter, enter, enter. 2.2004. If you do not move up to this, you can get there. I'm just telling you right now, just first thing you should do is jump to your horizontal line, 3.7712. And our last answer is 5.34. Ooh, careful, 342. How'd you do on that rounding? That's a 0. All right, what questions do you have for me? Your assignment is a worksheet. Remember what we did at the beginning. At the beginning, we worked on our replacing with trig identities. So expect that in the beginning. It's not a guarantee, but expect it. On the back side is your calculator work. If you think you need help with one or the other, start there.